For question 4, we're given 2 points, A and B, and they both lie on the line L. And part A asks us to find an equation for L in the form ax plus by plus c is 0. So to find the equation of this line, first we have to know the coordinates of the 2 points, so we do know those. And now we need to find the gradient. So to find the gradient of a line, we use the equation y2 minus y1 over x2 minus x1. You can remember that as y in the sky. As silly as it sounds, it does help you remember. So all we need to do is substitute in the y coordinates and the x coordinates into this. So the y2 coordinates are for b. So the y coordinate of b is -3. You have to be really careful with your signs on this as well, because you don't want to get them mixed up. And y1 is 4, because the y coordinate of a is 4. So we get a -3 minus a 4 all over the x coordinate of b, which is 8, minus the x coordinate of a, which is -6. Now we want to make sure we put that in brackets so we don't get confused with the signs. So then we just simplify that, so we get -7 over the 8 plus the 6, because the two negative signs make a plus, so we get a -7 over 14. Therefore we can simplify that down to -1 over 2 just by dividing both sides by 7. So you can really substitute it into any line equation you want, but I usually use y equals mx plus c. And now we substitute our value for m into there because we're finding the equation of the line. So we get y equals -1/2 x plus c. And now we need to find the constant c. So to do this, we can substitute either the coordinate of a in or the coordinate of b in. You can choose any, I'm just going to choose a. So when y equals 4, x equals -6, you don't have to write that, I prefer to. So we get a 4 equals a -1/2 times a -6 plus c. So all we've done here is substitute the y and the x coordinates into that equation. So we get a 4 equals a -1/2 times a -6. That is just a +3 plus c. And then we subtract the 3, so we get a c is 1. And all we have to do is substitute that into our original line equation. So we get y equals -1/2 x plus 1. And now all we do is to simplify this, we can multiply it by 2. So we get a 2y equals -x plus 2. And now remember, we want it in the form ax plus by plus c. So we get a 2y, just add the x and minus the 2 equals 0. And that is the equation of our line. So part B asks us to find the distance AB. And to find the distance of a line between 2 points, we use the distance equation. So that's x2 minus x1 squared plus y2 minus y1 squared. And all we have to do is substitute the corresponding x and y values into this equation. So it's quite simple, as long as you know the equation. So we have the square root of x2, which is 8, minus the -6. Now remember the brackets. Squared plus y2, which is -3, minus 4 squared. Now we just simplify that to 8 plus 6, which is 14 squared. Add 7 squared. And we should know 14 squared is 196. Add 49, which is 7 squared. And now we have to just tidy this up. So we get d equals the root of 245. And the answer needs to be in the form k root 5. So now we need to think of a way to get this into this form. Now typically when we want to break this up, we want two numbers that multiply to give 245. We already know one of them has to be a 5, because 245 is the same as root 5 multiplied by the root of a number, and that number needs to be a square number. So when you root it, we get an actual number, and that will be our integer k, if that makes sense. So we can square all the terms here, and we get 245 equals 5 multiplied by a number. 245 divided by 5 is 49, which is a question mark. And that works because 49 is then a square number. So we know that we can break this up into root 49 multiplied by a root 5. The root 49 simplifies into 7, and that's multiplied by a root 5. And that's our final answer.